so the lateral ventricle, remember, two lateral ventricles, C-shape with a little bit of a tail on them and a space. Yeah, are we okay? Everybody good? So that's the lateral ventricle. Close this back up and drop the cerebellum. All right, so it's better to look on this one anyway. So this now, the space, remember that odd shape if you wish, but the space is the third ventricle. And then this, in this model, the triangle that we have over here is fourth ventricle. Everybody see okay? So remember, third and fourth ventricles are attached by way of the cerebral aqueduct. And then right here at the very bottom of the fourth ventricle, the little opening right where I'm indicating here with this probe, right, goes into the central canal of the spinal cord. This is the median aperture. You cannot see the lateral apertures from the fourth ventricle on any of the models. But remember, those open up into the subarachnoid spaces. So we're talking about flow of cerebrospinal fluid. Excuse me. In this model, this is the interventricular foramen, this tiny little hole, which runs laterally into the lateral ventricle. So it attaches third and lateral ventricle to each other. Okay. In this model, the choroid plexus, remember, combination of capillaries and ependymal cells that produce cerebrospinal fluid. So it's the blue-purple, if you want, on the top of the third ventricle. You okay? She's got a great picture of the back of her head that you should ask her to send. Okay. And in the lateral ventricle, all of the blood vessels that you're seeing here. Okay. Choroid plexus. Okay. We'll come back to this model in a minute, but while I'm thinking of ventricles and the like. Okay, so remember, with this model, everything that's plastic is a space, and then we have brain tissue around the spaces. Right? So each C shape where the tail is one of the two lateral ventricles. This odd-shaped area, once again, is third ventricle. Attaching lateral to third ventricle is an interventricular foramen on each side. Fourth ventricle in this case is this area here, and the cerebral aqueduct attaches third to fourth ventricles. Everybody okay still? I can't see what you're seeing and what you're not. Okay. The face of the fourth ventricle, the roof of the third ventricle, and sort of the floor of each of the lateral ventricles. All this pink is choroid plexus in this model. And remember, this hole is not a hole. This is the intermediate mass, that little projection on either side of the thalamus that attaches the two to one another. Yeah, we're okay? Okay, so let's go back then, excuse me. If we then go back to this model, so what is the outline of the third ventricle is also the outline of the diencephalon, the difference being that the ventricle is the space, the diencephalon is the tissue on either side of the third ventricle. And it's made up of thalamus, which is this oval, and this mustard-colored sort of circular area here is the intermediate mass. So that was that hole you saw in the other model. The epithalamus is the pink that ends back here in the pineal gland. Excuse me. And this triangular area then below the thalamus is the hypothalamus. Projecting off of the bottom of the hypothalamus, this little stalk-like area is the infundibulum. And remember, that attaches the pituitary gland to the hypothalamus. Still good? Anybody who's not seeing these things? We're okay? Okay, so corpus callosum attaches the two cerebral hemispheres to one another. And since we've got this taken apart, so the brainstem, remember, is made up of what? The medulla oblongata in between my thumbnails here, so just about this much space here. The pyramids of the bulges on the front. The pons is higher than that, so above the medulla, and it's this oval area and the area behind it, so once again in between my thumbnails. And then midbrain or mesencephalon, again between my thumbnails on both sides of the cerebral aqueduct. If we put this,
So it's that part too?
it's, yeah, this piece here, you're saying?
Yeah.
Yeah.
And the brainstem was the lower part?
Brainstem was medulla, pons, and
Oh.
midbrain all together. Those three pieces make up, excuse me, the brainstem. Okay, so again, in this view, if you want, we've got the two cerebellar hemispheres, and remember this area here that connects the two of them is the vermis.
Mm.
We have two cerebellar hemispheres. We also have two cerebral hemispheres. Well, actually, we'll bounce around, I guess, a little bit, but there you go. Remember, this is the transverse fissure, which separates cerebrum from cerebellum. And if we turn the brain over, so we're looking at the top now. So this is the longitudinal fissure separating the left and right cerebral hemispheres from one another. So, turn this back over for a minute. We still look at the surface of the cerebrum in a minute. But remember, olfactory bulbs and tracts, and then a little bit difficult to see maybe on this one because the pituitary and infundibulum are there, but these are the two cut-off ends of the optic nerves, and not the infundibulum, but right next to it, where the two optic nerves touch one another, if you want, and cross, right? That's the optic chiasm. Remember, some of the fibers, about half the fibers from each eye, continue to the thalamus on that side of the brain, then to the primary visual area, but the other half from each eye cross over at this optic chiasm to the other thalamus, the other primary visual area. Excuse me. Okay, so since we're here, I mentioned cerebellar hemispheres. Remember, if we look at this midline view, then all the white that we see within the cerebellum, arbor vitae, looks like branches of a tree, yes? And then in between the branches, the gray matter, and around the periphery here, all that is folia, right? The gray matter of the cerebellum. Turn this over so that we're looking at the lateral view of the cerebrum. So remember, what we have here is the lateral cerebral sulcus, and if we start at this indentation here, that's the easiest way to make sure that you're in good position to follow that. But lateral cerebral sulcus on the side of the cerebrum. Then if you follow this in a little bit, so here we go across the top of the brain, mirror image on the other side, and that's the central sulcus, divides posterior or dorsal from anterior ventral. And so right behind the central sulcus, this raised area, is the post-central gyrus, primary somatosensory area. Right in front we have the pre-central gyrus, the primary motor area. I think that that's everything I've asked you guys for.
What is the mammillary body?
It's right here, but you can cross it off your list. I'm not going to ask you for that one.